Okay, problem 8 is where we're at. Find the midpoint M of the line segment joining -2, 3, and 4, 2. So I want the sum of the x values divided by 2 and the sum of the y values divided by 2. -2 plus 4 divided by 2 plus 3, and then 3 plus 2 divided by 2. Simplify that so you get 1 5/2. Make sure that's written as a point, not just 1 comma 5/2, okay, but the parentheses on both ends, etc. Okay, problem 9. Write the standard form of an equation of a circle with a radius 2 and center point located at -3, 1. Then graph the circle. So the standard form of a circle is x minus h squared plus y minus k squared equals the radius squared. H and k are -3 and 1. R is 2. X minus -3 squared plus y minus 1 squared equals 2 squared. Or x plus 3 squared equals plus y minus 1 squared equals 4. So I've got a circle of radius 2, and the center point is located at -3, 1. Okay, so -3, 1, and then using a radius of 2, I gather up 4 points around the center usually, and then draw the circle as best I can. Okay, problem 10. Find the standard equation of the circle. So here I've got a circle centered at 2, -3 with a radius of 3. So 2, -3 is my h and k value. X minus h squared plus y minus k squared equals r squared. In other words, x minus 2 squared plus y minus 3, y minus -3, y plus 3 squared equals 9 is the equation. Evaluate each expression if x equals -2 and y equals 3. So 3x plus 2y divided by 2 plus y. Well, let's see here. So 3 times -2 plus 2 times 3 divided by 2 plus 3. 2 plus 3 is 5. -6 plus 6 is 0. 0 over 5 is 0 for A. For B, 9x minus 5xy minus 6y squared. 9 times -2 squared plus 5 times -2 times 3 minus 6 times 3 squared. Okay, I'll take care of the squared expressions. -2 squared is 4. 3 squared is 9. Now multiply. Okay, 9 times 4 is 36. Minus 5 times -2 times 3, that gives me 30. Minus 54. 36 plus 30 minus 54 is 12, is the answer. Problem 12. F of x equals 2x minus 1 over x minus 4. Find f of 2 and f of a plus 4. Okay, so f of 2 means I got to plug 2 in for x. 2 times 2 minus 1 divided by 2 minus 4. 4 minus 3 is, 4 minus 1 is 3. 2 minus 4 is -2. F of a plus 4 means I've got 2 times the quantity a plus 4 minus 1 divided by a plus 4 minus 4. A plus 4 minus 4, this is a. 2a plus 8 minus 1 8 minus 1 is 7. So 2a plus 7 divided by a would be as simplified as I can get that. Problem 13, the relation S, which is the set containing the points 5, 3, 2, 7, negative 4, negative 6, 5, negative 2, and 0, 4 is given. Is S a function? If it is a function, write yes, and state the domain and range. If it is not a function, write no, and explain why not. Well, 5 is going to two different places, and you can't have that with functions. Okay, so no, since 5 does not go to exactly one y value, would be the reaction there. The problem 14 is the same type of problem, only S, the relation, S is equal to the set of points 1, 3, 2, 6, 3, 9, and 4, 9. Okay, so yeah, this is a function. For each x, there's only one y value. The domain is 1, 2, 3, and 4, the set containing, and the range is the set containing 3, 6, and 9. Problem 15, determine if y is a function of x. Yeah, so part A, there is no multiple y values. However, in part B, y is equal to plus or minus the square root of x plus 1. You could say something along the lines of like no, I guess all I'm looking for is yes or no. No, though, since 0, 1 and 0, negative 1 are on the graph. So if x is 0, y is 1, 1 squared is 1, and 0, negative 1, so 0, negative 1 squared is 1, 1 equal 1. Here I've got an x value going to two different y values, though, and you can't have that with functions. Okay. Problem 16, write each expression using set builder notation and then using interval notation, then graph the solution on the number line. Part A, the set of all x such that x is less than negative 4. Okay, there's how I write it using set builder notation and using interval notation. Okay, anything less than or equal to negative 4 means that I've got negative infinity to negative 4. I'm including negative 4, anything less than that, on the answer. Part B, x greater than negative 4. Okay, so I got the set of all x such that x is greater than negative 4 using set builder notation. By the way, using set builder notation, I'm just going to write exactly what I have in the line above there using set notation and set of all x if x is the variable. And then interval notation, so I've got parentheses. I use a bracket when I got a less than or equal to or greater than or equal to, and a parentheses if I got a less than or greater than sign. So I've got a parentheses here, and order matters. I want negative 4 to infinity. I wouldn't write like infinity comma negative 4. That wouldn't make any sense. Negative 4 has an open circle on it, and anything to the right of negative 4 is going to be okay. Part C, negative 5 less than or equal to x less than 1/3. The set of all x such that x is 5 to 1/3 in that order is my answer. I've got a bracket at negative 5 and a parentheses at 1/3. And because there's a bracket at negative 5, since I'm including negative 5, I need to include that in my answer. And anything between those two values is going to be a solution as well. Part D, set of all x such that x is greater than negative 12 or x is less than negative 12 or x is greater than negative 3/2. Okay, so I got the set of all x such that x is less than or equal to negative 12 or x is greater than negative 3/2. Anything less than or equal to negative 12 means I'm heading towards negative infinity. I got a bracket there, and because this is simply a greater than sign, not a greater than or equal to, I've got a parentheses, negative 3 halves to infinity. Now, whenever the keyword is or, I need to use, or I just write the word or. Or is only 2 letters. So, but you may see the union sign. That's also okay. And I'm including negative 12. I'm not including negative 3 halves. Okay. Anything less than or equal to negative 12 and anything greater than negative 3 halves is okay. Part E, x not equal to negative 3. Set of all x such that x is not equal to negative 3 would be the answer written as a set. As an interval, I get the basically any number except for negative 3. Okay. Part F, all real numbers. So here's how I'd write that as a set. And here's how I'd write that as an interval. Here's also how I'd write that as a set using set bracket notation. And I've got the entire number line shaded there. Let x be equal to 2x minus 1 divided by x minus 4. If possible, find f of 4. Well, 4 is not in the domain, so f of 4 is unavailable. In other words, I can't divide by 0, so f of 4 does not exist. State the domain of f. Well, 4 is the only number that is not in the domain, so the domain of f is the set of all x such that x is not equal to 4. Okay. Problem 18. State the domain of each function. Write your answer using set builder notation or interval notation. Okay. F of x equals x cubed plus 4x minus 1. So this function is asking me to get a number, any number I want, whatever number that is. I cube that number and then add 4 times that number and then subtract 1. I can do that to any number I want. So the domain of f is all real numbers. Part B, g of x equals 2x plus 6 divided by 3x minus 4. So the only thing I'm concerned about with g is that I can't divide by 0. 3x minus 4 equals 0. When I solve that, I get the set of all x such that x is not equal to 4/3. Okay, part C, h of x equals 2x divided by x squared minus 9. Well, again, I can't divide by 0, so I set x squared minus 9 equal to 0. X squared equals 9. Take the square root of both sides. X would be plus or minus 3. That's what I don't want. That's what I don't want. K of x equals 2x divided by x squared plus 9. Well, again, the only thing I'm interested in is the denominator, and that I can't divide by 0. So if I set the denominator equal to 0, x squared equals negative 9. Yeah, that's going to be all real numbers. It's going to be okay, since when I square a number, I'm never going to have a negative. So that's x squared plus 9 will never be 0 in the denominator. Part E, f of x equals 5x minus 1 divided by x squared plus 4x minus 5. So let's see, the denominator is going to factor as x plus 5 times x minus 1. And so I don't want x to be negative 5, and I don't want x to be 1. Any other number is going to be okay, except for those two. Part F, g of x equals the square root of 1 minus x. So 1 minus x greater than or equal to 0, and when I add x to both sides, x is less than or equal to 1. Yeah, anything less than or equal to 1 is going to be okay to use. Anything that's bigger than 1 means that I'll have a negative underneath the square root sign, and the square root of a negative is not a real number. Okay, part G, h of x equals the square root of x squared plus 5. Well, I'll never have a negative underneath the radical when I square a number. And when I add 5, I'll still never have a negative. So the domain there is all real numbers. Okay. Part H, k of x equals the square root of x plus 3 divided by x plus 1. Okay, so I know I can't divide by 0. So x can't be negative 1. I get that. X plus 3 has to be greater than or equal to 0. So x has to be greater than or equal to negative 3. Okay, it looks like anything that is greater than or equal to negative 3 is okay to use, only don't take negative 1. Negative 1 is an issue. Any other number is going to be fine, though. For that. Okay, and why don't we stop right there?